Welcome to the second part of our video, or rather the question that we're busy with. So here is the presented question as it has been. We've already done 5.1, 5.2, and 5.3, and now we are just finishing off 5.4 and 5.5. The reason why we divided the video into two is because we didn't want to have long videos, right? So now I advise you, before you proceed from here, try to calculate the values that we got for 5.1, 5.2, and 5.3. Pause from here, try to get those values yourself. If you think you can't get those values, and then go to the previous video just to see how we worked out the entire questions for 5.1, 5.2, and 5.3, because from here, we're just going to go ahead with 5.4 and 5.5. And 5.4 and 5.5, we can tell that they relate to analytical geometry. But like I say, trust me, this question was not from a second paper of mathematics. It was from the first. It was not from the second paper of mathematics, it was from the first paper, of which in most cases, students believe that analytical geometry or the application of analytical geometry is in the second paper. But hey, here is a surprise. It was on the first paper rather. Hence, that's why I divided into two as well. So we did the algebra part first. Now we are doing the other part, which is 5.4 and 5.5. But without wasting time, in 5.4, we are required to calculate the length of AB. We are required to calculate the length of AB. At this point, by the way, we have already calculated the coordinates of B and the coordinates of A. But to make it make sense, let's analyze the diagram in a closer look. Let's take a closer look at the diagram. Now, to get the length of AB, which is this, it's going to be easy because I already know the coordinates of A. I know that the coordinates of A is -6 and -6 as calculated from the previous video. And I know that the coordinates of B is 0 and 6. And then to get the length of AB, I'm not going to stress. I'm just going to use the distance formula. And the distance formula states that. Now, here are the functions for the two lines, and the coordinates of B is 0 and 6. The coordinates of A is -6 and -6. And then to get the length of AB, I just have to use the distance formula that states that x2 minus x1 squared plus y2 minus y1 squared. The square root of that will give me the distance of AB. And from here, I can name this my x1, y1, x2, y2. It doesn't really matter which order. And in this case, I will have, look at this. I will have -6 minus 0 squared plus -6 minus 6 squared. This is going to be -6 squared plus -12 squared. Therefore, this is going to be -6 squared will give me 36 plus -12 squared will give me 144. And then I will have square root of 36 plus 144 is 180, which means that my answer, if I punch this on a calculator, I will get 6√2, which is roughly equal to something like 13.42. So that's the length of AB. That is the answer for 5.4. Now, before we approach 5.5 together, first try it first you can pause the video, try to get the triangle, because what we are required to do, we have to calculate the area of triangle ABC, which is like some serious analytical geometry that has to happen there. Pause the video from here, try to calculate the area of triangle ABC and see if you would get it yourself. And then you can leave the answer on the comment as to how did you approach it. But otherwise, we're going to have to approach it for those who may not understand how to go about in a question like this. Now, in order to calculate a triangle, an area of a triangle is equals to half the base multiplied by the height. Always, regardless of whatever shape or type of a triangle you have. For those who don't know, we have different types of triangles, and they go with their names: equilateral, isosceles, obtuse triangle, in whatever different forms you may have. To get the area of any triangle is half the base multiplied by the height. First of all, I will complete the entire diagram to show how it looks like. So triangle ABC is this triangle. And from this triangle, I know that the base for this triangle will be BC. So BC represents the base of my triangle. But then I need to know the height of the triangle. And to construct the height of the triangle, it's going to be the line going through up until the center of BC there. And if the line goes through up until the center BC, I can name this point F, where the interaction, I can name it F. It doesn't really matter, even if it doesn't have a name. But I know that part of this line is going to be half BC. And this one is going to be half of BC. So now I need to get the height H in order for me to can calculate the area of ABC. That's the procedure that I have to follow. If I don't follow that, I won't get the area, because area is half the base multiplied by the height. Now, obviously, if I construct the height, it's going to strike a 90 degrees angle here. Never mind my diagram, it may not be accurate, but that's what you should understand. It will form a 90 degrees here. If it forms a 90 degrees there, somehow I already know the point of A is minus 6 and 6 and minus 6 and minus 6. And I know the point B is 0 and minus 6. And I already know the distance of AB. If I know the distance of AB, I calculated it previously, it was 6 root 2, right? Now, with this information, there's one point that I need to determine, which is point C. This point here, point C. I know that point C is the x-intercept. Point C is the x-intercept of the inverse function, the x-intercept of the inverse function. Now, if I can get that, then I can somehow determine my height in order to determine the area. Now, this is how I'm going to go about. So to get the x coordinates of the inverse function, I will let y to be 0 in order to get the x-intercepts. So if I let y to be 0 and I solve for x here, I will have minus 2x is equals to minus 3 if I take this to the other side. Therefore, if I cross multiply there, I will have that minus x is equals to minus 6, which means x is equals to positive 6. Therefore, point C is 6 and 0, because like I say, the way we represent a point is the x-intercept first and then the y-intercept. Now, with that information, it means now I can determine the length of BC. The length of BC will be such that, again, I will use distance formula. x2 minus x1 squared plus y2 minus y1 squared for the points B and C. Now, this is going to be 0 minus 6 squared plus 6 minus 0 squared, which is going to give me 36 plus 36. Which makes BC to be square root of 72, not 76. which makes BC to be square root of 72. And square root of 72, if I simplify this further on a calculator, I'll find that this is 6 root 2, but that's not the point. Now, I have BC. If I have BC and I have, let me break this down again. If I know the length of BC and I want to find the height h, right? I want to find the height h. I know that for triangle, remember I named this side F. Even if I don't name it anything, it doesn't matter, but then I think it's going to make sense if I name it F. I know that for triangle AFC, I can use Pythagoras theorem to determine my height h. Why so? Because I know that BF is going to be square root of 72 divided by 2 because it's half of BC. Also, FC is also going to be square root of 72 over 2, like that. Because I have two triangles in between there, but I'm only using that because I want to get my height h. So I have two sides. I have side AB, I have side BF, and I can determine h. How so? Like this. AB squared is equals to h squared plus BF squared. AB squared is equals to h squared plus BF squared. I'm using Pythagoras for this triangle here. Because I know the values. So now let's calculate that. We're trying to get our h for the height. And I know that AB, it was square root of 180 squared, or h squared is equals to h squared plus BF, which is 72 over 2 squared. Therefore, we'll get that h squared is going to be 180 minus 72 over 4. H squared will be, if I simplify this, I will get 162. And to get h, I'm just going to put square roots both sides. Therefore, h is going to be square root of 162, which is 9 root 2. So now I have the height, I have the base, I can calculate the area. So now here, if I have the height, I know that area of triangle ABC is going to be 1 over 2. The base is BC times the height. Therefore, this is going to be 1 over 2. What is my base? My base is 6 root 2, or square root of 72. Let me just put it as square root of 72 times the height, which will be 9 root 2, like that. Whatever answer I get. So whether I put it as, even if I don't put it as square root of 72, I can put it as 6 root 2. I can put it as 6 root 2. Therefore, if I punch that on a calculator, I get that the area is equals to 54 units. So that's how you get the area of triangle ABC. So this is how we answer the whole question in full. Thank you for watching. Make sure you subscribe to our YouTube channel. Follow us in all our social media platforms so you can get updated whenever we upload videos like this, which is going to assist you to prepare for your exams. I'm Mr. My Money. This is Simplified RSA. We are the guys who makes it look easy. And don't forget to contact us whenever you want to inquire about our private lessons. We do offer private lessons at a very reasonable fee. Send us a WhatsApp or an email to any of this number. Thank you.
Simplified, us are the guys who makes it look easy.